Alright, today we are working on section 10.6 quadrilaterals. And again, a quadrilateral is an enclosed four-sided figure. What's interesting about this, and it's kind of relating to your triangle, which has 180 degrees with the sum of all three angles. A quadrilateral, it's the sum of all four angles will equal 360 degrees. Okay? In fact, if you think of a rectangle, it has four 90-degree angles in it. 1, 2, 3, 4, and 4 times 90 will give you 360 degrees. That's where a lot of that comes from. Another one that you can look at is if I were to take this quadrilateral and cut it in half, you can see that I get two triangles. And remembering what we learned last week, that a triangle has 180 degrees, there are two triangles that equal 180 degrees. Add that together or multiply by 2 and you will get 360 degrees. Okay, everything coincides. So angle 1 plus angle 2 plus angle 3 plus angle 4, adding the four of those together will equal 360 degrees. Go ahead and hit pause if you have not already copied this down. So if the guest teacher would hit pause and give the students a few minutes to copy this down. Go ahead and do that. Alright, what you're going to do now is solve for the value of x. So if you would, again, hit pause and allow the students to find the missing angle. Alright, so we're going to take 146, 116, and 40 degrees. We're going to add those together, and we get 12, carry the 1. We get 8 plus 2 more is 10, carry the 1, and you get 302 degrees. We're then going to take 360 degrees and subtract the 302 degrees, and the difference, which is 58 degrees, is the value of x, and that difference again gives you the value of that missing angle. So 58 degrees. So again, recap, just add the three angles together, just like you did with a triangle, but you were only given two angles, finding the third. In this case, we're finding 3 of the 4 and subtracting from 360 to get the missing angle. Go ahead and solve this one for the value of x. So please hit pause. Alright, so now what we have is 90 degrees and 90 degrees. Hopefully all of you saw that these two angles, since they didn't give you an actual angle, that they always represent 90. So 90 plus 90 is 180, plus 19 more is going to give me 199 degrees. Now we're going to subtract that from 360 degrees. And when you do that, you get 10, borrow from the 6, borrow from the 3, make this 15, and we get 6 and 1. So 161 degrees is the value of x. Questions on that? And again, you can certainly ask the guest teacher, and you can refer to this information as well. Now what I want you to do, I really don't want you to copy any of this down. I'm gonna you can find this information very easily in your textbook. It's the same information that you would find in there on this particular section. So don't feel obligated to write this down. In fact, don't. What I want you to do right now is to just simply listen as I go through all of these different quadrilaterals. Again, looking at quadrilateral, This top one up here, it's just a four-sided figure. Okay, and none of the angles are congruent. It's just anything that is four-sided is a quadrilateral. We're going to slide down to this. This is a unique quadrilateral, the trapezoid, because it is exactly only one pair. Okay, you can only have one pair of parallel sides. That's what these little arrows are representing on here. Okay, so you can only have one pair of parallel sides. If it has two pair, then it cannot be considered a trapezoid. Okay, now going back to the quadrilateral and sliding down, all four of these have some very similar characteristics. The first one is a parallelogram, and it rightfully gets its name parallel because it is mostly talking about that. The opposite sides are parallel. Opposite angles are also going to be congruent, and opposite sides are going to be congruent. Now when we slide down to this rectangle, this is also a parallelogram. It meets all of the characteristics that it has stated here as a rectangle. So when we look at this rectangle and we ask ourselves the question, is this a parallelogram? Look at the definition. Does it have opposite sides that are congruent? Yes, it does. Are the opposite angles congruent? Yes, they're all 90. Opposite sides are parallel. Are these two sides parallel and these two sides parallel? Yes, they are. So you could also call this a parallelogram. The best answer, however, is a rectangle because all angles are 90 degrees. Okay? So opposite sides are congruent and parallel, and they have 90-degree angles. Okay? Now we're going to slide over to this, which is a rhombus. It is also meeting all the parallelogram characteristics. Opposite sides are congruent and parallel, and opposite angles are are congruent. But all four sides are congruent. The angles aren't necessarily right angles. Okay? Opposite angles are congruent, but the characteristic that's really unique about a rhombus is that just all four sides are congruent. So now we're going to slide down to the square. And if we look at a square, it says that all sides are congruent, and they are. All angles are 90 degrees, and they are. Opposite sides have to be congruent and parallel as well. So, parallelogram. We look at this square. Can we call this square a parallelogram? Again, opposite sides are congruent, opposite sides are parallel, and opposite angles are congruent. So yes, you can call this a parallelogram. Can we call this square a rectangle? Okay, and the characteristic of that again are opposite sides congruent and parallel. Yes, they are. Do all the angles have 90 degrees? Yes, so we can call this a rectangle. The question, however, can we call this rectangle a square? And in this case, the answer is no. You cannot call this rectangle a square. Why? Because all the sides are not congruent. Okay? They have to be all congruent on a square. Can we call this square a rhombus? Well, the definition of a rhombus just simply says all four sides are congruent. Are all four sides congruent? Yes, so we call this a rhombus. Can we call this rhombus a square? No, because it does not have 90-degree angles. Okay, it has all the other characteristics, just not that. So it can be a little confusing. You have to be very careful in the way they're asking the question. So now let's look at the next one. And it says classify the quadrilateral. Actually, what I want you to tell me are all the different shapes, okay? All the different quadrilaterals that are made up in this particular shape. So go ahead and give me some of there are 4 different ones. In fact, I'll label them 1, 2, 3, 4, and tell me what those are. So go ahead and do that right now. If you'd hit pause, please. Thanks. Alright, for this particular one, we're going to name quadrilateral 1 being a square. And if we look at these angles, they are 90 degrees. They appear that way. So therefore, it would be a square. If we look at the quadrilateral number 2, this one would more than likely be considered a trapezoid. Some of you might have called that just a quadrilateral. If you did, that would be because this line and this line were not parallel to each other. They're close. They are close, but some of you might have noticed that it's off just a little bit. Same thing for number 3. This would be considered a trapezoid. And number 4, that is considered, I think most of you looking at this can see, you might have called it a square. A few of you might have called that also a rhombus. If it is a square, then you're saying that these angles are 90 degrees. Okay? If you're calling a rhombus, you're saying that it doesn't necessarily have 90-degree angles, but they're close. But opposite sides are still congruent, and all 4 sides, or I say angles, are congruent. All 4 sides are congruent, meaning that it is a rhombus. For letter D, I want you to list all the possible quadrilaterals names that you could give this shape. So go ahead and hit pause. So the first one is going to be, probably the best answer to this, is a square. Number 2, the next best answer to this, well, it could be many. One, you could call it a quadrilateral. The third one you could call it is a, because it has 4 sides, we could call this a rectangle, because again it has opposite sides congruent and parallel, and it has 4 right angles. The fourth one we could call this is a rhombus, because it has 4 congruent sides. And we could call this also a parallelogram, because it has opposite sides congruent, opposite sides parallel, opposite angles congruent as well. So that would be a parallelogram. Now the question is, can we call this a trapezoid? And the answer to that is no, because it has 2 pair of sides that are parallel. A trapezoid can only have, not a very good drawing. I apologize for that. A little difficult to do sometimes on here, as you know. That's better. 2 parallel, or excuse me, 1 pair of parallel sides, and those would be parallel. Okay. Another way of drawing a trapezoid might look like this. Okay, and where this is parallel to this. Okay, cannot have 2 pair of parallel sides, so it cannot be a trapezoid. Okay. Good luck on your homework today. If you do have any further questions, please refer back to your book as well, along with your notes. But that your textbook, again, for this section has all of those different quadrilaterals listed, and you can refer to those. Please read those questions very, very carefully, as so you know exactly what exactly they're asking, and refer back to the definition of what they are saying that the shape could possibly be. Again, if you have questions, you can watch the podcast again. You can also watch a podcast for the next lesson that we do for tomorrow on My Big Campus. Have a great day.